Alright, problem number 5. How many positive integers less than or equal to 100 have a prime factor that is greater than 4? Alright, well, my hint to you on this one would be to use complementary counting. And what complementary counting means is that you count what you don't want and then subtract it from the whole. So, we've got positive integers less than or equal to 100. Okay, so we know there's 100 of them. And one question that, often comes up is do we include 0 or not? And because this is positive integers, 0 is not actually positive or negative. So positive integers are just whole numbers, so they'd start with 1. So we have 100 integers that are less than or equal to 100. Okay? And but if we try to count the number of integers that have a prime factor that is greater than 4, there's a lot more prime factors that are greater than 4 than there are less than 4. Okay? So it's actually easier to count the prime factors, or count the integers that do not have any prime factors greater than 4. Okay? So what are those going to look like? So let's rephrase this. So what is the complement of what we're looking for? The complement of what we're looking for is how many integers have no prime factors greater than 4. Okay, how many integers have no prime factors greater than 4? Okay, so what are we looking at? We're looking at numbers that are of the form, well, there's only 2 prime numbers that are less than 4. It's 2 and 3, right? So we're looking for some numbers that are of the form 2 to some exponent and 3 to some other exponent. Okay? And we can eliminate all of those, and then what's left over will be only the prime factors, the integers that have prime factors greater than 4. Okay? So if we eliminate any of the numbers that are of this form, then we can subtract that from the whole, which is 100. Okay? So, let us take a look at what those numbers could look like. All right, so let's look at powers of 2. All right, so let's look at 2 to the n. So we would have, 2 to the 0 is 1, and we'd have 2, 4, 8, 16, 32, and 64, and so on. Okay, so that gets us started. And I'm actually going to make a table here. So let's make a table that looks like that. So these are all powers of 2. And let's look at also the powers of 3. 3 to the m. Okay? So we'd have 3 to the 0 is 1, we'd have 3, we have 9, we have 27, we have 81. Alright, and we're just looking for integers that are less than or equal to 100, so I'm just going to work with this for now. Okay, so let's look at, if we create combinations of 2 to the n and 3 to the m, we ought to be able to make a table. So 1 times 1 is 1, 2, 4, 8, 16, 32, 64. Okay, so I'm just multiplying the row by the column. Okay, and then down this column, of course, we're going to get 3, 9, 27, and 81. Alright, so 2 times 3 is 6, 3 times 4 is 12, 8 times 3 is 24, 16 times 3 is 48. And let's see, 32 times 3 is 96. And if we take 64 times 3, we're going to get something that's greater than 100, so we don't really worry about that. Alright, so let's go across this row. So 2 times 9 is 18. 4 times 9 is 36. 8 times 9 is 72. And if we take 9 times 16, it's going to be greater than 100. So now let's see. 27. 27 times 2 is 54. And then if we take 27 times 4, we get something over 100. So, and then here if we take 81 times 2, it's over 100. So really we're just dealing with these numbers. These are the numbers that do not have any prime factors greater than 4. And we can count them, right? So across here we have 7, and we have 6, and we have 4, and we have 2, and we have 1. And if we add that up, let's see, we have 6 and 4, and then 7, 1, and 2, so that's 20. So we have 20 numbers between 1 and 100 that do not have any prime factors greater than 4. Okay, they're of this form, 2 to the n times 3 to the m, and there's no other factors. There are only factors of 2 and 3. So any other numbers between 1 and 100 that are not of this form are going to have factors greater than 4. Okay? So we know we have 100 numbers between 1 and 100. So if we subtract 20, then what we have left over is 80, and that will be the number of positive integers that are less than or equal to 100 that have a prime factor greater than 4. Okay? Because what we did, we subtracted out all the ones that don't have prime factors greater than 4, and what we have left over are all the ones that do. Okay? Because then all the numbers between 1 and 100 are either going to have a prime factor greater than 4 or not. Okay? So if we subtract the ones that do not, then what we have left over is the ones that do. Alright? That's complementary counting. So, there you go. The answer is 80.